All righty, here we go. Welcome, geometry friends. This is the last, aren't you glad we're friends? Praise the Lord. All right, this is the last video, last assignment for Chapter 2. This is the Chapter 2 review. Chance to get a little more practice in before we party next week or at the end of the week. So page 130, 5, 7, 11 through 25, 29 through 43, and 47 odd. I'm going to be working through a number of these with you. Namely number 11, 19, 25, 29, 33, 43, and 47. Just can't help but be helpful. So here we go. Let's jump right in. Number 11 is where we're going to start. I think you can figure out a lot of the inductive patterns before this one on your own. But number 11 says, determine if the conjecture is true. If not, write or draw a counterexample. So number 11 says, if C is the midpoint of AB, then AC is congruent to segment BC. So I drew a picture of what that's saying. And so it's telling us C is the midpoint. And so that always implies, by definition of a midpoint, that this piece, segment, is congruent to this segment. AC would be congruent to CB. And that's the conclusion that they have there, that if C is the midpoint, then the two segments AC and BC must be congruent. So that's the definition. There's no real counterexample here, so we're going to have to say true. It only has to be true one way. If you remember from the practice test, there was one like this where we actually found it false and we're able to find a counterexample. But the difference between that and this one is that was a biconditional, where it said it's the midpoint, so it creates the two congruent segments. But then it also had to be true that if you had two congruent segments, it had to be the midpoint. That's not necessarily true. This is only a one-way conditional. And so we're only looking at it from one direction. And if you have a midpoint, then you definitely have two congruent halves. So true. Number 19. Number 19, kind of doing one from each section here. It says, write the converse, inverse, contrapositive of each conditional. Find the truth value. Don't forget to find the truth value of these, especially if it's a fill in the blank. You don't want to miss easy points. So let's just practice writing each one. We have, if angle X is a right angle, then angle X is equal to 90 degrees. Alrighty, so the converse would simply switch these two because we have here X is a right angle. That's my hypothesis. The conclusion is angle X equals 90 degrees. So for the converse, we can write if angle X equals 90 degrees, then angle X is a right angle. Alrighty, so let's see, is that true? If an angle is 90 degrees, is it a right angle? That's the definition. When they write a converse, when you write a conditional statement and it's the definition, there's no counterexample. You're not going to have any right angle that's not 90 degrees. So we can say that this is, in fact, true, which, as a sneak peek, that also tells us that our inverse is going to be true. But let's just check it out. Inverse. So now for the inverse, we're going to insert our not here. Okay, we're going to keep it the original way, but we're going to insert the not. So we'll say if angle X is not, I'll write it in caps, a right angle, then angle X, we'll go ahead and do it this way, doesn't equal 90 degrees. Okay, so we kept it the same order, but we just negated both sides. So that's our inverse. Is that true? So if an angle is not a right angle, then it can't be 90 degrees. So can you ever be 90 degrees but not be a right angle? No. And as we can see, so that's also going to be true. Inverses and converses always have the same truth value, I think. Alrighty, and then finally we have our contrapositive. Okay, that is where we're going to do both. We're going to swap these and we're going to not them. So here we go. If angle X doesn't equal 90 degrees, then angle X is not a right angle. Okay, now let's see, up until now, I think most of the time we've never had one where all the statements are true, but if you take a look at that, if an angle is not equal to 90 degrees, then it can't be a right angle. That's true because that's part of the definition. And so this is a perfect example of a good definition. You could also write this, therefore, as a good biconditional. It doesn't ask us to do it, but I can't help myself. You could say angle X is a right angle if and only if it equals 90 degrees. And so you would be correct there. And you could also then make a definition and say right angles equal 90 degrees. But anyway, we didn't have to do that. We only had to do the three statements and the truth value. All righty. Moving on from that. Hopefully that's getting a little easier. That was 19. Let's look at 25. Okay. So 25 is an example of drawing a conclusion based on an equation, which can maybe seem kind of weird. So I wanted to go ahead and walk you through one of those. It says that the expression 2.15 plus 0.057x gives the cost of a long distance phone call, where x are the minutes of the phone call, and then the answer, so we should go ahead and maybe just put an answer, is the cost of that phone call. Alrighty, and so we're supposed to say if we can draw the conclusion. Well, number 25 says, Paulo makes a long distance call that lasts 10 minutes. So they're telling us the number of minutes that he's making his phone call. Can we conclude anything? Yes, we can, because we can input the number of minutes here, and then that will tell us the cost. So this problem, in what it's trying to say, draw a conclusion, is saying use this formula to draw the conclusion of how much his phone call cost. So we just need to do 2.15 plus 0.07 times 10, because that's, he says his phone call lasted 10 minutes. Okay, this is back in the day when you actually had to pay for your long distance phone calls. We're kind of past that at this point. And so that's going to come out to 2.15 plus 10 times 0.07 is just going to move the decimal place one spot. So that's going to be plus 0.7. So that phone call cost him an extra 70 cents. And so we can go ahead and add these, and that will be $2.15 plus another 70 cents. You can imagine there's a zero here. That's going to be $2.85. Oh, let's see, did I not get that right? Checking. Okay, $2.85. All right, we'll come back to that, but that looks good. 10-minute phone call, perfect. So we can conclude the cost of his phone call. Okay, let's take a look at now number 29. 29. Again, same thing. Determine if a true biconditional can be written from each conditional statement. If not, give a counterexample. Now, so they're asking basically if this is a true biconditional, and really it's just an excuse to have us find the midpoint, because number 29 says if a segment has endpoints 1, 5, -3, 1, then its midpoint is -1, 3. And so we have to decide is that a true biconditional? So there's two ways to look at this. First of all, let's see, is this in fact the midpoint? So it's a nice little chance for a midpoint review. And so we're going to add our x's and divide by 2. So we're going to say 1 plus -3 divided by 2. That is -2 divided by 2. That is -1. Okay. Then we're going to check the y's. We're going to add them and divide by 2. So 5 plus 1 divided by 2. So that's 6/2. And that is equal to 3. And so we do in fact see that this is point -1, 3. So it's true that if your endpoints are 1, 5 and -3, 1, then your midpoint is -1, 3. So that seems true. Watch out. Now you see why it's kind of a tricky problem, because if that was just a conditional statement, we would be fine. If those are your endpoints, then M is your midpoint. But it's a biconditional, which means it would have to be true the other way as well. In other words, if -1, 3 is the midpoint, does 1, 5 and -3, 1 have to be your endpoints? And the answer is no. And I'm not going to calculate that, but let's just go ahead and illustrate it. Because if you have your graph and we have back one, up one, two, three, and we say this is your midpoint, and then the other endpoint over one, up five, one, two, three, four, five, and then back three, one, two, three, up one. Okay, so you can see what we prove one way is yes, that's the midpoint. But if this is your midpoint here, do these have to be your other endpoints? No, I could have a midpoint here, an endpoint here, and an endpoint here. In other words, what is that? This is 2, 6, and this here is 1, 2, 3, negative 4, 0. And so you can see those, the negative 1, 3 is still the midpoint of those two lines. Those two endpoints. So that's kind of the trick to this question is be careful. Biconditional means it has to be true forward and backwards. It's true forwards. Negative 1, 3 is the midpoint. But if negative 1, 3 is the midpoint, it doesn't have to mean that the other two are the endpoint. As you can see, I could have other endpoints, and I could keep going on forever. There could be endpoints out here. So this is not a true biconditional. No. There. Actually, let's write this in a better spot rather than just cramming it there. No, there could be other endpoints. So can't help but say that again. Make sure, if it's a biconditional, make sure it's true both ways, forward and backwards. If it's just a conditional, you just got to make sure it's true the direction they are stating it. Okay, after 29, let's take a look at 33. 33 says, again, complete each statement to form a true biconditional. So this says Trey can travel 100 miles in less than 2 hours. If and only if his average speed is what? So how fast would he have to be traveling in order to go 100 miles in under 2 hours? Well, miles per hour, we just go ahead and calculate that by taking our distance divided by our time. And so 100 miles divided by 2 hours means he'd have to be going 50 miles per hour. Or we could write it, 50 miles per hour. Now, it says, let's just check that. So if we make that a conditional statement, if Trey can travel 100 miles in less than 2 hours if his average speed is 50 miles an hour. Well, it would actually have to be, his average speed would have to be greater than, because if he goes 50 miles an hour, he's going to just make it in 2 hours. This says in less than 2 hours. So technically, your answer needs to be greater than 50 miles an hour. That's what this means. His speed would have to be greater than 50 miles an hour. That's true. And let's check the converse, because remember, let's make sure it's true both ways. If his speed is greater than 50 miles an hour, then Trey can travel 100 miles in less than 2 hours. Yeah, that works. So in this case, it is true both ways. And so we can say that's what the speed would have to be greater than 50 miles an hour. And then he could travel 100 miles an hour, 100 miles in less than 2 hours. And again, check it both ways. In this case, it works. And notice again that it can't be equal to 50 miles an hour because it has to be less than 2 hours. If it said less or equal in 2 hours or less, then we could just say it's equal to at least 50 miles an hour. All right, 43. Again, kind of another unusual one where they're having us do, practice a lot of these logical things, but still having us do math calculations. So I want to provide you with a help. So number 43, we're supposed to use an indicated property. Well, actually, no, it's different instructions for 43. 43 says Kim borrows money at an annual simple interest rate of 6% to buy a car. How much did she borrow if she paid $4,200 of interest over the life of a 4-year loan? Now, you might be like, interest? What? I don't understand any of this. Well, no, they give you the formula. They give you this formula, I equals PRT, where I, let me get the right color here. I is the interest. That's the amount of money you pay on top of a loan whenever you take out a loan. That's why you want to be careful about taking out loans, because you don't only pay back what you borrow, you pay back a certain amount of extra money based on the time that you borrowed it for. P is the principal, not like me as a vice principal, but as the principal amount. That's the amount borrowed, basically. The principal is how much you borrowed. So that's actually what we're looking for in this question. We don't know how much she borrowed. The rate is the interest rate. That is what percentage of what you borrowed are you going to have to pay in extra money for how long you take to pay back a loan. And then the T is the time. How long of a loan? There's a big difference if I borrow money from you for a day versus a year versus 30 years. And so that's going to determine how much interest I end up paying back on top of paying back whatever amount principal I borrowed. So here's the numbers we already have. We have the rate is 6%. The interest that means extra money they paid back was $4,200, and the loan was 4 years. Now, so we're supposed to solve this, but then this is also a proof question where we have to provide our reasons. So let's go ahead and solve it first, and then we'll provide the justifications for each step. So we have our formula. I equals interest equals principal times rate times time. Then we can substitute everything in. So we can get to my interest was 4,200 equals my unknown principal times my 6% rate. Now, here's another trick, which is why you should use the videos. Whenever you calculate a rate in one of these problems, you put it as a decimal. And so 6% as a decimal is 0.06. All right, and then the time is 4. Okay, so now we've plugged everything in. I can simplify this before I solve for P. 4,200 is equal to the principal, and we need to go ahead and calculate what 0.06 times 4 is. That's going to be 24 with 2 decimal places, so that's actually 0.24. So P times 0.24. And now we just need to do a little bit of algebra to get the P by itself, and that's if I divide by 0.24. So 4,200 divided by 0.24. That's going to tell us what P equals. So let's go ahead and find out. I don't know that off the top of my head. It's not without concentrating extra hard. 4,200 divided by 0.24. Okay, let's see. It comes out to 17,500. So moderately expensive car. Fun fact, don't ever recommend you buy a new car. Always buy a used car. 17,500 equals the principal. So what that means is that, where's our friend Kim? Kim bought a car for $17,500. It took her 4 years to pay it off. And by that time, she'd paid $4,200 extra in interest. So the actual cost of her car was $21,700. But anyway, we just had to find the principal. And I can box that. And since it's a word problem, no naked numbers. Let's put some money on there because that's money. Now you're like, that was enough. Well, that was our statements. That was our S. Let's go ahead and do our reasons, which actually is the easier part, hopefully, of this problem. So let's think. Okay, so first off, we had, get this out of the way, it's in the way. We had the formula. Where did we get the I equals PRT from? That was given to us. They gave us the formula. Thank you, because a lot of us would not even known what that was. Then how do we convert that into 4,200 equals P times 0.06? Well, look, we had these things up here. They told us what those were equal to, and all we did was, that's right, substitute. We plugged it in. Substitution, property of equality. Okay, and then how did we get from 0.06 times 4 to the 0.24? That we just did arithmetic, which we can call simplify. Hard to think and spell at the same time. And then how did we get to the 17,500? We divided by 0.24, so that is the division property of equality. Okay, so there we go. Kind of a tricky problem, and why I wanted to work through it. But again, they just give you the formula. You got to plug in. It's basically you're just solving an equation, but you had to get past the plug-in phase, which might have thrown you off. It might have been tricky to know that 6% should be calculated as 0.06. So anyway, that's why I'm here to help. But the right side, you should be pretty good at. They gave you a formula. We turned it into real numbers by substitution. We simplified one side and then just did a simple algebraic division, and then we were able to solve it. So that's the heart of what you want to be able to be taking away from this chapter, especially 2.5. Okay, and then 47. 47 is it just says solve for x. So we're looking at x, and this is going almost back like to chapter 1, which is why I thought it's kind of a nice review problem. Glad they include it. We have 3x and 2x plus 5. We need an equation. And so really our only options are either those two angles are equal to each other, or they add up to something, or they subtract to something. So that's what you have to consider. We can see that this angle, this whole angle here, is a right angle. So that's a clue, because that means we know that this entire thing must be 90 degrees. So that's important, because I have no reason to believe they're equal to each other. Be careful. Don't get in the habit of just saying, oh, look, I see two angles. They must be equal. In the drawing, they don't. In my drawing, they look equal. In the book, they don't look that equal. But unless you have a reason to think they're equal, don't just do that. In this case, it makes a lot more sense that if I add up these two angles, they're going to equal what they've given me, that little red box. They're going to equal the 90. And so there we go. That's my clue for the equation I need to write. That 3x plus the 2x plus 5 equals 90. And now we can just rock and roll and solve this. All right, I can add my x's, combine my like terms. So that's 5x plus 5 equals 90. And we can bust out our algebra like it ain't no thing. Subtract my 5, cancels out. 5x equals 85. And I can divide by 5 because that's the opposite of multiplying by 5. All right, simplify. And so then we get x equals 17, I believe. Let's check our answer. Always check your answers, make corrections. No sense in doing it wrong. X equals 17. And it does not say find the two angles, so I'm not going to plug it back in. It just says find the variable. There it is, x equals 17. All righty. Now, we don't have to justify each step. I'm really tempted to, but you probably won't bother. So, but you could. Notice you could go ahead and justify each step, just like we've been practicing. You know, how did we come up with this equation? Well, that was the definition of a 90-degree angle. Actually, be the segment addition postulate. These two angles equal the bigger angle. So segment addition postulate. Then we combined like terms or simplified. We did the subtraction property of equality. Then we did the division property of equality, and we had an answer. So it's just beautiful. It's just amazing how all this works together, and the amazing skills and knowledge you're all gaining, those of you who are trying and doing your best. Alrighty, please reach out if you have any help, because the next stop is the Chapter 2 test celebration. And so, again, I really want you to do well, and I'm happy to help in any way. So please reach out to me.